Hi there. I wanted to make a video to explain this molecular shape and molecular polarity. So the first thing you can see this molecule has two bonds. Just a reminder that the lines are two electrons being shared between the, like here, between the oxygen and the hydrogen. So and then these are lone pairs of electrons. They're on the central atom. We call the one in the middle the central atom. So these are lone pairs because they're not bonded. So in this water, we have two bonds and two lone pairs. And if we use our chart on our orange sheet, that tells us then that we're talking about a bent shape. So that would be the molecular shape. The polarity, I made this chart to help. You want to ask yourself these questions when you're trying to determine if the shape is polar or not. So overall, does that water have a negative end and a positive end? So the first thing you have to ask yourself is the shape bent or trig pyramidal? And it's bent. So if you say yes, then automatically the molecule is polar. And if it has lone pairs around the central atom, it's automatically polar. So here's another example. So this has 1, 2, 3 bonds, 1 lone pair. So I use my chart, 3 bonds, 1 lone pair, trig pyramidal. To determine the polarity of the molecule, again, I ask myself this first question. Is the shape bent or trig pyramidal? Yep. So then I would say, yes, the molecule is polar. So remember, this negative lone pair up here makes it so that if I were to draw a circle around, it would be negative up here and positive down there. So now wait one second. Sorry, guys. Oh, there's one hiding here. So let's talk about this one. Hopefully we can get some that are a little bit more interesting. So here we go. It has 3 bonds and no lone pairs. So this is going to be 3 bonds, no lone pairs on the central atom. This is trig planar. And this is a symmetrical shape. So as long as these 3 are all the same and we know there's no lone pair, then we know that this is a nonpolar molecule. If I go through the chart, I would have said, nope, it's not bent or trig pyramidal, but are the atoms around the central atom the same? Yeah, because they're all chlorines. So then I know it's going to be a nonpolar molecule. So let me do this one next. So this one is even more interesting. So for this one, for the shape, I put the electronegativities in here because I'm going to use those later. So it has 1, 2, and we only count that as 1 bonding area. So 1, 2, 3 bonding areas, and that leads us to, and no lone pairs, that leads us to trig planar for the shape. So once we know it's trig planar, now we're ready to look at whether or not this is a polar molecule. So again, we ask ourselves, is it bent or trig pyramidal? No. Are the atoms around the central atom the same? So here's our central atom. We have 2 hydrogens and we have an oxygen, so they are not the same. So then I have to look at whether there's any bond dipoles. So what I want to do is look at electronegativity differences and see if there's any that fall in the range of 0.5 to 2.0. And if there are, then the molecule's polar. If there are not, then it's nonpolar. So let's do that. So if I were to calculate the electronegativity difference for these electrons here, hydrogen is 2.1 and carbon is 2.5. So that's a 0.4 difference. So there's no bond dipole. I don't draw that arrow there because they're sharing, essentially we just say that they're sharing equally. Same thing here. Those two are only a 0.4 difference, so they're sharing equally. But here, there's a 1.0 difference. So here we're going to draw that bond dipole pointing towards the oxygen. So you don't necessarily have to draw it, but you have to realize it's there. So if we go back here and we say, are there bond dipoles? Yes. So that makes this a polar molecule. Okay, so now let's talk about this molecule. So this one, you just have one bond and really don't have a central atom. In fact, it doesn't even really fit one of these on our shape. But if you just have two things together, they're always going to just be a linear shape. So I can use this chart again, and I can say, is it bent or trig pyramidal? No. Are the central atoms around the same? You know, this kind of questioning doesn't totally work because it's only the two and there is no central atom. So when I do a linear and I decide whether it's polar or not, I just look at the difference between them. So because these are identical, both with an electronegativity of 2.1, the difference between them is 0. But let's say I had a, let's say it was linear, but it was this. Now I would want to, because they're not identical, I need to figure out the difference in their electronegativities. So hydrogen is 2.1, chlorine is 3.0. So now we have a difference of 0.9. And that is, remember, 0.5 to 2.0 is where we're going to add those bond dipoles. So there is a bond dipole, which means that chlorine is pulling on those electrons more than hydrogen. And this is not symmetrical. There's no way to balance that out. So that this here, this one, if we had done it, would have been linear, and then we would have had polar. So let's do a couple more. So here we're going to do this H, the sulfur's in the middle, central atom, 2 bonds, 2 lone pairs. That leads me down to the bottom of this, which is bent. So then I use my chart. Is it bent? Yes. So it's automatically polar because of these lone pairs. This one's a little more fun because you're probably getting really good at, if there's lone pairs around the central atom, it's automatically polar. It's these other ones that are a little bit more interesting. So here we go. We've got, and again, I don't think this one is on your orange sheet, but there's no lone pairs. And, oh, actually it's right here. So 2 bonding areas and no lone pairs is linear. So then I go through the questions and are the atoms around the central atom the same? No. Here's our central atom. If these were both sulfurs or both nitrogens, then we'd say yes, and the molecule's going to be nonpolar. But if we say, are the atoms around the central atom, they're not the same. Now we have to calculate the bonds and see if there's any bond dipoles. So I would look on my periodic table. I know that carbon is 2.5, nitrogen is, I'm losing it, 3.0. So these guys are 0.5 difference, which is right at that beginning where you would want to draw that dipole. So I already know that this is going to be a polar molecule. But we can check this one too. So sulfur is that one's 2.5. So there's no bond dipole there, but because if you go through the chart, if there are any bond dipoles, then for sure the molecule's polar. And it is, I hope. It says that underneath. Yep. And then let's do number 8. So 8, I've got too much stuff going on here, huh? So this one, we have 4 bonds, no lone pairs. And if I use my orange sheet, that tells me that it's a tetrahedron shape. Then I want to go through my head. I want to think, okay, well, it's not bent or trig pyramidal. Are the atoms around the central atom the same? Bromine, 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 bromine. Yes. So then the molecule is going to be nonpolar. If I had, let's say, this was a fluorine, then I wouldn't have been able to say they're all the same. And then I would check the bond dipoles. And I can see like carbon is 2.5, 4.0. So there's for sure a bond dipole there. So automatically, I wouldn't even have to calculate whether there's one there. I know that this is going to be polar if that had been a fluorine, for example. So I hope that helps. And then I will do a Google Meet too.